We'll be back from that short break. It is still a good afternoon. Back specifically for chemistry still. We are going to look at something small. We want to complete the food additives. We previously had looked at the thickening agents. We looked at the preservatives. We looked at the preserving agents, the flavoring or sweetening agents. We also looked at the bulking agents. And currently, I want us to look at the thickening agents, but don't forget to subscribe. Invite friends. Please invite friends to join us. Inform your neighbor and the neighbor's neighbor to inform the neighbor that Mto is live streaming about food additives right now. I want us to look at the thickening agents first. And I'm sure we shall get this work. Let me hope you've tried the question you sent in the group. For those who are in the group, please try that question first. Check the question and see it before. So we are going to look at thickening agents. Thickening can also be known as the glazing agents. They are the ones we want to look at. They are commonly and widely used and applied in our daily life. Let's start with the function. We are looking at food additives. For those who were not with us in the first live streaming, we introduced food additives. To bring you on board, we said we are going to look at each food additive, the function, the examples. We are going to give how it works. We are also going to give the challenges associated with the long-term use of these food additives, and then the properties that make these food additives suitable for use. So we are now looking at thickening or getting agents as food additives. We said these food additives, they are non-food compounds or substances which are added to food to improve the food in many aspects. Now, the thickening agent improves the viscosity of food. We are looking at the food additives. The thickening or getting agents improve the viscosity of food. The word viscosity means thickness. Improves the thickness. The soup to be heavier, not to be too much watery. The soup not to be too light. Let me take an example. If you've ever used Ona, there is a difference between the viscosity of the apple flavored Ona and the mango flavored Ona. One of the two is more viscous than the other. So the thickeners improve the viscosity of food, like the thickeners in Royco and the smart those people use. They improve the thickness of soup, the viscosity of soup, not to be too watery. So we can give examples of these thickeners. The thickeners are almost the same. They use the same things to be. They are thickeners, they are stabilizing agents, and sometimes they act as the other bulking agents. They have the same action. We have the likes of emulsifiers. Actually, no. We are going to give the likes of pectin. Pectin is a good example of a thickening agent. We have starch powders. Starch powders such as wheat flour. We are giving examples of thickeners. There are many examples. We cannot finish them. We have the likes of the Irish potato powder. They dry the Irish potato and add it to soup to thicken the cassava flour. All these are thickeners. And what they do to make this gelatin, there is also gelatin, very nice. This gelatin. So they get bones. They grind them to powder and add them. Actually, they preserve them and use them to make the food additives like the curry powder, the loic, and so many other things. They add other ingredients to make the curry powder that thickens, that increase the viscosity or improve the viscosity of food. How do they work? Excuse me. How do these getting agents or thickening agents work? They work almost in the same way as the other bulking agents. They form interconnecting molecules that form interconnecting molecules that trap liquid molecules together. And this increases the viscosity, the heaviness of the soup. What could be water, what could appear as water, has been trapped. The smaller molecules of the liquid have been binded together to form very large molecules. And these very large molecules will appear as heavy molecules, very large and heavy molecules of food or soup. So the other action is these thickeners interact with the food to form a gel-like fluid, which mixes with the soup, increase the viscosity. To have soup that is appearing as a gel with no gel, you give an example of Vaseline. Some Vaseline products are gels. You see the appearance of the Vaseline. So some of these interact with the food to form gel-like fluids that improves the viscosity of the food. Actually, they work majorly in solutions, in solution foods, for example, the soup. So the properties, these getting or thickening agents are very stable, even at very high temperatures. Those properties we said are cut across all these food additives. They are very soluble in water, that they will distribute evenly throughout the food. To go on, they almost have the same side effects. But to add on, some of these are extracted from bones, like the gelatin. The pectin is a protein. These ones, when overused, they sometimes lead to increased body weight, which is a side effect. But they almost have the same side effects: allergic reactions and digestive discomfort. To move on, we have other food additives we call stabilizers. But before we go to those food additives, the stabilizers. Anyway, let's first look at the stabilizers. Tim Flair. The getting agents, we said the getting all of food additives, we have both natural and synthetic. Tim Flair is asking, are even getting agents synthetic? There are even others that are laboratory processed. In laboratories, they process all of these ones. They process gelatin, they process pectin. They can all be processed. We can even give the examples of tomato. In some cases, when you add tomato to sauce, there's that way the tomato improves the weight of soup. You can talk of vegetables. Have you ever chopped eggplant and put it in soup? You fry it very well and you cook it, then smash it to form a fluid, a semi-fluid gel. There's that way the vegetables, when added to soup, increase the viscosity of the soup. Yes. So we can give even the synthetic, the natural ones, they are there. The vegetables are good thickening agents. The stabilizers, the major function of the stabilizers, the major function is to maintain the texture of food. Have you ever gone to a restaurant? Those people bring you food, let's say bean sauce, prepared from beans. They bring a very good container of that soup. When the cooking oil is on the surface, the water is in the middle, the beans have settled at the bottom of the plate. To me, I feel that food unpleasant to be eaten. A food with a uniform texture, it means that food, the oil is well mixed with the water and the solid food in it. Even when the food is left for any time, for a long period of time, the food will not decant. The solid particles in food will not decant. The light liquid will not float on the heavy liquid. So the stabilizers come in. What do? They come in to increase the interaction between the oil and water and then the solid food in the solution. In short, these stabilizers prevent settling, degradation, the food to degrade, degradation, decanting of food. These stabilizers do so by doing this. So you can give very many examples. You have very many examples. We have the likes of emulsifiers. I don't know if the word emulsifier is. The word emulsify is to chop oil from small particles to fine droplets is emulsification. If you have ever looked at nutrition in the duodenum, digestion in the duodenum. So these emulsifiers come in to chop the oil molecules or to break down the oil molecules to fine droplets and make sure that these oil molecules finally mixes with water to form a uniform layer. We also have the pectin. Pectin is a good stabilizer. The gelatin is also a good stabilizer. They work by forming a gel solution, which gel solution, actually they work by breaking down the fat molecules, the large fat molecules, to fine droplets, which easily dissolve and mixes finely with water. That is for the emulsifiers. And then the gel formed by these two, the pectin and gelatin, is a bit of low density, is actually of a relative density that is not too high, not too low, for the solid particles to sink or for the water to sink in the solution of that food. So these emulsifiers, the pectin, form a gel-like solution of relative density in which the solids or less dense liquids will not float or sink for the heavy ones. So looking at the stabilizers, they are soluble for the properties and very stable even at high temperatures. There is a question here. I'm pleased, sir, but it is when there is Joy here. Trijuche, Joy. I'm sorry if I've pronounced your word poorly, but the lessons are always, if you are not in the group, we have Moto online group, WhatsApp group, where we always give updates for lessons. Please, if you don't have that number, I'm going to read it. Keep active. But you can also notify me on my WhatsApp number. It is 0708 88 34 75. 0708 88 34 75. Or you can reach us via our WhatsApp number, Moto online, 0703 27 8231. 0703 27 8231. For any help, we are ready to help. So these are some of the examples of stabilizers. Their work is to maintain the texture of the food, not to separate the components of the food, to have a uniform layer of the food. Let me hope I'm clear. We've given examples, and I've given you how the stabilizers work. I don't know if you have a book where you note. Excuse me. So how stabilizers work. You said they work by breaking down large and light oil or fat molecules to fine droplets of relative density that mixes uniformly with water and the solid food. So that's how the stabilizers work. They work by breaking down large and light oil or fat molecules to find droplets that are of relative density that mixes uniformly with water and the solid food, not to have any compartments in the food. So these are what we call stabilizers, and this is how they work. We said they have the same properties. We maintain the other two properties, and maintain the other two side effects and mitigations. I don't know if you have any question before we continue. Team Freya, I'm so grateful for the activeness. So, can I use pectin and gelatin in both thickening and stabilizing it? Yes. The gelatin and the pectin are both stabilizing and thickening agents. They work as both. They are both stabilizing and thickening agents. Because almost the stabilizing and the thickening agents have closely related functions. I hope I've answered your team. Before we go any further, if you have somewhere to note, let's try to read this question and we try to answer it together. If you have somewhere to note, the question goes, Miss Balaba has a restaurant in Iganga. The customers have these days abandoned her restaurant because of poor taste of food. If you have a pen, highlighting that point. If you have a pen, underline this: poor taste of food, unpleasant scent, underline this one too. And the food gets spoiled every short time. So you also underline this: spoiling after a very short time. The appearance of cooked food is not attractive. Also underline this. They are bringing out what they need you to follow when responding to the question. And they are also saying that it's not attractive and the soup is always too dilute. Do you see that? The soup is too dilute. So the soup is not thick enough. So they continue by saying that she wishes to acquire different substances which would be added to her food to produce meals attractive to her customers. She has contracted you as a chemistry student, well knowing that you can advise her on the right products or substances to buy. So there is some support materials here of some food additives and the food she gives to the customer. The question is, write a piece of advice to her on the category of the substance or product. The question is there in the group. Use of the different substances. Are you seeing this? The use or the uses are the functions we've been given. The category is simply stating that what she's missing is the natural and synthetic food additives. So that could be the correct response for this. Natural and synthetic food additives. You give examples. Actually, you also give a reason that would improve the quality of the food. For example, you start giving stabilizers, thickening agents, because they mentioned about the dilute sauce. You talk about the preserving agent because they mentioned about the food spoiling very fast. We talk about the flavoring agent because they talked about the flavor, the taste, and the scent. We also talk about the dyeing agents since they talked about the appearance. So the response to part A would be natural and synthetic food additives, natural and synthetic food additives that would improve the quality of food, such as you give those categories we've been giving: thickening, flavoring, you go on. Then the uses, you give the use of each. Thickening agent to improve the viscosity of the food. Flavoring agent, improve and enhance taste and aroma or scent of the food. Preservatives or the preserving agents to increase the lifespan of the food. Like that. The side effects have been given. Then evaluation is giving the differences and similarities. So start by giving the similarities as, let's say, they all improve the quality of the food. That is a similarity. Then start giving the difference. This one does this, the other one does the other one, and the other one does the other one. Let me hope I've given a clue. So if you can, please write your responses somewhere. You take a snap and send the responses to my WhatsApp number, to my inbox. I'll respond to you. You may fear giving the response in the group. I'll give you the collections. So these are the stabilizing agents. Let me hope you don't have any other question about the stabilizing agents. Team is asking, we haven't looked at the dyeing agents yet. Let's look at them briefly here. So the dyeing agents, excuse me. So the dyeing agents, the major function they serve is to improve and enhance appearance of food. Imagine you brought sauce that is colorless and sauce that is a bit colored, the white rice and the brown rice. There's that way the brown rice looks palatable compared to the white rice. So the dyeing agents, they are used to enhance and improve appearance of food. Simply that. What they do, they bind to the food molecules. And when they bind to the food molecules, you can note this, they bind to the food molecules by forming bonds with the food molecules. As they bind to the food molecules, they actually give the food the appearance and overall color pigment that is a mixture of the color of the food and the color the dyeing agent has brought. So in that way, the appearance of the food is changed. These food additives, the dyeing agents, are very stable. Even at extreme temperatures, the pink remains pink, the red remains red. So, and they are very soluble. They distribute evenly in solutions to reach every part of the food. The examples, the common examples of these dyeing agents, we have the azo compounds. The azo compounds. We have the phenyl compounds. These are all food additives. They improve or they enhance the appearance of food. What was white turning to any other color of this dye. So on the properties, you can add the light reflecting ability of these dyes. They have the ability of reflecting light. They reflect light of the color they have. They are shiny to give the food that bright appearance. So you can add all those ones to the properties. They are non-toxic. So their toxicity is at very low levels. So you can give all of those as properties. You can add on and give tomato. The tomato improves color also. The sauce with the tomato is different from the sauce without tomato. You can talk about the carrots. I think we very well, we can all bear me witness that the carrots change color of the soup. We have the turmeric. We know the turmeric. The turmeric have a purple appearance, an orange appearance. They are like ginger. Very good dyeing agents. So all these are some of the examples. So all food additives are non-toxic. Actually, they are less toxic. You can take that as a property. But the dyeing agents are also brightly colored. They are brightly colored to give the food a shiny appearance, to improve that appearance of the final product. So I'm talking about food additives. Tim, I think we've looked at the dyes now. Yes, the red and the purple amaranthus, dodo. We can talk about the likes of, there are some people who add beetroot to juice. The beetroot changes the color of the juice from yellow to purple. All those, the beetroot, you can give that as an example of this. It is the purple cabbage. All of those change the appearance of food when added to it. So the food gets a very attractive appearance. I think with that, we can move on to the next food additive. We said they have almost have the same challenges associated with long-term use. And I want more contributions like Tim does. Tim does it well. I haven't seen Zahara today. So to continue, you can remind me of the food additive I've not talked about. Glazing agent. I've not talked about the glazing agents. The glazing agents, for these ones, they are used to coat. Let me think you've ever seen cakes. The cakes are coated with an outer layer of icing sugar to keep the real cake inside safe for a long period of time. So the glazing agents are used to coat food so as to increase on their appearance, because we use different designs, and shelf life. There's that way those cakes last longer, even when the conditions are not favorable. The glazing agent is the only one that is affected, but the food molecule inside is left well preserved. You take an example of these tablets. The tablets, they are always coated. The active ingredient is inside, but it is always sugar coated outside. The sugar outside is to preserve the active ingredient inside. It serves many functions. So these are some of the examples. We have the beeswax. They use beeswax to coat food. Why do they use this beeswax? The beeswax is non-toxic. The beeswax is refractive, reflective. It reflects light to give the food that bright appearance. It forms a smooth layer on outside of the food to give it a very nice appearance also. Let me hope I'm clear. That layer it forms, or the coat it forms on outside of the food, keeps the food in a favorable condition inside that coating, not to be affected by external factors like the microorganisms. So the properties that make these glazing agents suitable for use, you can talk about the non-toxicity, the reflecting ability. They are not soluble. For them, they are insoluble, that they cannot easily be dissolved by water and moisture, expose the food. You can talk about, let me hope you're noting the points, non-toxicity. They are insoluble in water, hence cannot be dissolved by the moisture or water to expose the food. They are stable even at high temperatures, that they even maintain their chemical properties and physical properties. Even in extreme temperatures, you can set those properties. There are many others. So these ones work by forming a smooth coating or a smooth layer on the food that serves as a protective layer to the action of moisture in the air and the microorganisms that would make the food go bad. So these are some of the functions of, how the glazing agents work. We talked about the properties, and you can give the same side effects and mitigations. If you have any questions before we continue, pause them. Do you have any questions? Maybe we don't have. Let's finally talk about the antioxidants. Excuse me. Antioxidants. The number you see there is Muto Online WhatsApp number. You can check on it. You can join the group using that number, or you can text this the administrator add you. We said we are Muto Online. We are streaming in live right at our usual school, London Chutis, Nursery and Primary School. It is located in Kasenge Buddu. Don't hesitate bringing your child. It's a good school. Let's look at the antioxidants. The functions of these antioxidants is prevention of spoilage of food by air oxidation of lipids. When I talk about lipids, I talk about oils and fats. So the antioxidants prevent spoilage of food. And this spoilage of food prevented is by the air oxidation of food, of lipids. Mumanye kigambo kutunguna kyekitegeeza. Have you ever made food like ice cream? If they don't add these antioxidants, nga bakola ice cream, when making ice cream and yogurt, the ice cream you get always has an unpleasant taste because of lancidity of these fats, of these lipids in the milk. Lancidity is early oxidation of the fats in the food. It is commonly applied in milk products, formation of milk products. Simanyi oba kibayita okutunguna mu Luganda. You can check on the meaning. So these people usually use things like ascorbic acid. They usually use ascorbic acid because it is a good antioxidant. Sodium benzoate, and so many others. So what they do, when you get side effects, challenges, the other challenges we talked of, the allergic reactions and so on, the mitigation for the side effects brought about by the antioxidants is taking foods rich in vitamin C. Is the mitigation. We always take food rich in vitamin C. For example, the fruits. But the same properties, these antioxidants are soluble. They are very stable even at high temperatures. They are non-toxic or less toxic. and so many other properties we've talked about. So with that, if you have any question to pose, please you can push it, we can respond to it. The glazing agents, they are not the same. They are different. The glazing agents, the antioxidants may be in the glazing agents. The preservatives may be in the glazing agents, may be components of the glazing agents, steam flare. So the glazing agents may be made of very many things. They may be flavoring agents, they may be dyes, there may be antioxidants and so many other food additives in the glazing agents. I hope I've answered you. They are not the same. If you look at the functions, let me hope I've responded to your question. Ask any question, please. Zahra, you're most welcome in the group. If you don't have any question, we can call it a lesson. I think those are some of the food additives we have to look at, the commonly asked ones. And with that, maybe we shall welcome any questions. We shall post some questions in the WhatsApp group about food additives. Try them, send them for corrections and marking. We are Muto Online. Teacher Alan Sereko. I sign out for this session.